Hi, I'm the home distiller, and today we're going to finish off the mount for the DC motor on the Sieg C6 lathe. There's a couple of boo-boos along the way with the milling, nothing too serious, just a couple of mismeasurements and had to cut a couple of slots to get things to align properly, which I may need to increase to give me some adjustment to get belt tension, etc. And we made some test cuts, so she's really got some balls now. There's more power than the lathe can handle really, which is pretty much where I wanted it. Whereas previously it was lacking in a lot of power. So I'm very happy with it now. I have to make the enclosure for the electronics and rewire it. But I'm waiting on some meters to arrive. I plan on putting a voltage meter and an amp meter on the motor so I can see what kind of load it's under. Yeah, so this video is mostly going to be dubbed over. See how we go. So let's get cracking.
So here I am making up the mould, just using a bit of talcum powder and brushing it around with a brush, as I can't find my little bit of pantyhose with some talcum powder in it, because funnily enough I don't wear much pantyhose. So, and I'm just riddling the sand on top, so there's no lumps or anything like that. It's just a bit of wire, like fly wire mesh. You want to make sure your sand's tamped in fairly well. This is a casting sand that I made myself from fine washed sand and clay kitty litter. I've made a video on it if you want to see how I made it. Now I could have done this as an open mould without the this piece that I'm ramming up now, but it would have had a fair bit of shrinkage, and that centre of the pattern would have had a divot in it as it shrunk away, and having feeders and risers helps prevent that. So I'm just going to use a screw in the middle just to pull it out, because I don't really need to use this pattern again. So, and I was making a few other castings at the time, so I'm using my split flask, so I can make up multiple patterns in the one flask, and I'll just lay it down and open it up like this and reuse that flask. So I've already got the aluminium melted. I'm just removing all the dross. Now it's advisable not really to be doing this in shorts, but you know, I like to live dangerously sometimes. So that was a bit of light salt that I added then, which is potassium chloride, I think, as a flux, and then some washing soda as a degasser. And also I should have cleared out my holes a little bit, or made sure this rod was, my handle was hot, so it just kind of melted the aluminium on the way through the holes of the crucible. As you can see, it was hard to insert through the hole and remove it. So there's the pattern, and the two other castings I made. They all worked. The other two castings are actually some slingshot ammo mould. And here I am just cutting off the sprues. This is actual speed. I did have to have a little rest afterwards. So we just put it in the mill, and this is sped up of course, and just use the fly cutter to clean up the bottom and square the edges. I didn't really need to do this, but it just made measuring the holes a bit, like marking out the holes a little bit easier. And I think it just makes it look a little bit nicer too, and a little bit cleaned up. I'm just using a bit of WD-40 in that pump bottle there. And I'm getting a little bit of a funny line pattern on it because my gibs weren't very tight. So this Sieg mill isn't really the best. Same with the lathe, unfortunately. It's okay for light duty stuff, but and I'm just squaring off the draft off of these mounts, mainly just so I can hold it in the vise a little bit easier when I drill the holes to mount it. None of this is really needs to be dimensionally accurate, as long as the hole spacing is right, which turns out I got it slightly wrong. So I end up having to cut some slots in the bottom 2 holes, which I think I'm going to have to put slots in the top holes anyway, just so I can put tension on the belt. And I'm going to have to make some more soft jewels soon. These ones are getting a little bit chewed up. Unfortunately, these 2 holes that I drilled here for the motor weren't quite spaced right, so I had to actually cut some slots. And also this here I had to cut a bit of a rebate in the back, so the motor mounting bolts had enough clearance so they weren't pushing up against the lathe when this whole mount was bolted up onto the lathe. So I just, rather than counter boring, because I don't actually have any counter bores, I just milled out a rebate across the back, or a slot. So here's my first big boo-boo. I was milling with the quill hanging out a bit too far and then in the wrong direction there, and as you can see it's grabbed and reefed off to the side. This mill is not rigid enough to be climb milling like that. So it doesn't really matter, because once these bolts are in, you don't see it's only just pulled off a little bit, about 1 millimeter to one side. Everything still mounts up fine, as you can see. And these are more of these socket head cap screws that are a little bit too long for everything, but these are through holes, so, and they just go through into the body of the lathe, or in between the ways underneath the headstock there, so you're not going to see them or anything anyway. So here's our first test spin. The gearing setup that it has at the moment means its maximum RPM is about 1,000 on the headstock, which I think would be about 4,500 on the motor. So it's about 4 to 1, 4.5 to 1. But as you can see, at low RPM, it just can't maintain it. It has no pickup as to what actual RPM it is, so it can't maintain the RPM very accurately. So here we try some quite deep cuts on a bit of fairly soft aluminium with some high-speed steel. This is, I think, 0.2 of a millimeter per rev, so quite a deep cut. This is way too much, but I'm just seeing what happens. And what happens is it welds a big chunk of molten aluminium to the tip of the tool. You can see there's quite a lump there. At this stage is when I realised I really needed some cooling on the fan, on the motor, sorry. And this poor little carbide tool is no more. A bit of mild steel and a much too deep cut. And it basically just bent the little mounting screw for the insert. The insert survived, but the tool holder did not.
So as you can see, seems to be working quite well. I definitely need to get some cooling on it. The fan on the back isn't going to be, would be fine at higher RPM, but when you're running it slow, it's not moving any air. So I've got a like a squirrel cage fan that I'm going to put on there, and I think I'm also going to put a little piece of reflective tape on the fan blade so I can actually just quickly check the RPM on the motor for curiosity's sake, but just poking my little laser tacho in there. There will be a tacho on the headstock, on the chuck, sorry. There will be a tacho on the chuck, so I'll know what speed it's doing. So the next video we'll be making, or rewiring this lathe, probably making a new, I might make a whole new faceplate. And there's a switch on there that I might use for the forward and reverse. I'm not sure, I have to pull it all apart and basically work out what I'm doing. But I do want to have the ability to put it back to it was, just in case that motor fails, or I decide I want to sell it and you reuse the motor in another lathe or something along those lines. So yeah, so that'll be in some upcoming videos. We'll make the enclosure and we'll go from there. So I'm the home distiller. Thanks for watching.